You can follow along, or if you're working ahead, continue to do that. If you have questions, please let me know. So the first part after, so we're gonna do two sections on monitoring. One is gonna be on Windows and another on Linux machine, which is your Kali. That's the easiest for you to access. Let's do a share. So if you look at your lab page, go down to lab 10 and you would see that in lab 9, I also shared the link to download your compressed virtual machine. So if you don't have access to the drive, you can download it, but make sure you extract it before you load it. So I put a note of that here. Okay. So make sure that we download the virtual machines that we need if you don't have access to the drive. All right. So I downloaded my CIS-41A and it is in my downloads folder. I right click and I choose extract all. So what I did was I went to the link that's provided in here, which took me to the Google Drive. And I click download anyway. And it's going to come down as a zip file in my downloads folder. Okay. Which is this right here. Notice that it is zip. So we want to right click and choose extract all. That's how you can bring the virtual machine to your computer. Now, keep in mind that if your laptop have limited storage, right, like RAM and things, sometimes virtual machine might not be ideal, but this is how you can use it on the school computer that can run VirtualBox and then in our lab systems. So once I click extract all, it's going to give me this folder, which is CIS-41A Win10 VM. And I open up my VirtualBox app by searching for VirtualBox, click it open. Then I would mount my virtual machine by clicking add, go to the downloads, and I see my extracted folder, just like the way that you do Kali. Open that up, and I would find the blue file, right? It should already have the RAM and the processor that you need. So if you need to change it, you can go to settings and modify it, and then I would click run. So basically I extracted the downloaded virtual machine, and I used the extracted folder to load the virtual machine into VirtualBox. That's going to take a minute to open up. Once it opens up, you are going to log in using this password. It should be CIS-41A student. In your virtual machine for Windows, you are going to use perfmon or performance monitor. And in that, you need to add these counters. So these counters is going to allow you to pull the data of the system relating to these particular components, right? Like your disk, your memory, your processor. Also issues with network connection, NetLogon, which is a service that we use for Windows authentication, right? Any kind of packet direct receive filter, peer name resolution. So some of the things that we talk about today, I wanted to incorporate it so that way you can add the counters so you can gather the data for analysis. Okay. Some of you might have seen this before because I have another lab that's similar to this, but this one is more for analysis. So once your Windows system, your virtual machine is booted, we're gonna log in. If you need help, let me know. Stop me, okay? Because I don't want you to keep struggling with the issue and then you can't progress in your lab. So let me know. All right. So once we're logged in on our Windows taskbar inside our virtual machine, let me move my caption over here, right? The step is that we're gonna open up the app, right? Or your performance monitor management console. So in the search option here, you're gonna do performance monitor. You can just type in performance and be able, so we're just gonna click it open. Remember that the account that we're logged in have some privilege in this. Otherwise, you won't be able to just, use it as a regular user. All right, so here's Performance Monitor. This is a Windows tool for the Windows environment. On your Performance Monitor, what you're going to do is you are going to select, right? Make sure you click on the monitoring tools. And on the left, you should already see Performance Monitor. So you can click the left or the right. But on the left, after Performance, Performance, you click on Monitoring Tool and then Performance Monitor. Here, we're going to be able to add counters. Like I said, counters are just elements that we can include in our data set, right? Like memory, processes. So once you click Performance Monitor, on the left under the drop down, you're going to click Add, which is the little green plus sign, and it's going to list all the counters. Then we are going to, and they are alphabetized. So the funky thing about the interface for this is it's going to drop you right in the middle. You're going to have to scroll up and down to select. So I'm going to scroll to L, where logical disk is going to be. We're interested in the storage space, right? We talked about looking at applications and indicators relating to that or relating to data for your application. Anytime that you see an arrow in operating system, that means that there are sub elements to it. You can look at it, but we're going to select everything that relates to logical disk. So you just click logical disk. And it would include everything, total, all instances. That's mean all drives. And in my virtual machine, I only have C and this. But in a real server, you might have many drives here. You're going to click it on the logical disk and click Add, right? So it's going to put it to the add list on the right. Then we're going to go down to the next item, which is memory. So select the next item here on the list and then click Add again. So it's going to go to the list on the right. And we would do the same thing for process and processor. Remember that these two things are different. Process include process information, where processor include your core information, your multi-core information. So we're going to scroll down to P. And we're going to select process, click add. So it's going to show you what you're adding there. And then processor, the same thing. And in the virtual machine, because there's 4 core, it shows 4 instances from 0 through 3. That counts up 4. And then TCP, IP performance. So go down to T. So we're going to keep doing that. So we're going to do the diagnostic, the regular one, right? Yeah, the performance diagnostic, not the per CPU. We're interested in overall. So click Add. And then we're going to go up to net login. So we're going to go to N and click Add. And then go down to packet direct. But remember make sure that you select receive filter. So you can have many options here, but we're going to do the receive filter, click add, and then pure name resolution. Okay. Like we talked about peer-to-peer connection, it has to use pure name resolution, your PNR. Bye. So once you added these, you're going to click OK, and it's going to pull all the counters. The graph, at first, is going to be very hard to distinguish which is which. and it's color coding down here. We'll take care of the visual aspect later. So at this point, we want a screenshot for number 6. And then what you're going to do is you are going to look at the information here, right? And you are going to be able to answer. So what I want to do is I want you to draw out some data that you kind of see already based on live, right? Live monitoring. We are not recording anything yet. We're going to put it into a data set for later evaluation after we generate the data collector set here. So what we're going to do is we are going to look at the average page fault. So if you scroll down, because page fault is part of the memory section, it's a little bit further down. It's like maybe almost halfway. You would see the page fault information, right? And then you can also look at like average, maximum, minimum. Sometimes it doesn't have a value. So what I wanted to draw out from there is just to show you that you can select the individual counter that you have added or the sub-element of the counter and be able to get some statistic information from it, right? So now what we want to do is we want to look at like, oh, was it fault per second? Yeah, page fault per second. I had clicked the wrong one, but page fault per second is there. It's a little bit more up, but it's part of memory section or counter. And then you can also go up. I think the percentage symbols are at the top. So percentage processor time for number 7 should be like the top one. So you can click that and you can see the minimum, the maximum, and the average value. So percentage, yes. So page per second, it just means the rate that it loads the page per second. I had clicked that by mistake. Yeah. Scroll up a little bit. The faults per second is the error that you see with memory per second. Yeah, page fault and then fault per second. Let me see. Yes. Let me see you're looking at. Yeah. So there's page fault per second for process. You're right. So it page fault per second for process, that means that it's related to the process. The process page fault, that means that the error that it generates when it processes the page per second is this rate. Whereas when it writes to memory, if you go up to fault per second, page fault per second for memory is slightly different. Yeah, you can record both if you want to look at both, but it's really depending on what you're addressing, right? Like if you're monitoring your processor, like you said, you can go down to that. Okay. Yeah, on Monday I just referred to the one for the memory, but yes, you can also include the process information. Percentage for processor time, like I said, is at the top. So we can see, remember how we talked about we need to look at like what is normal, what's not normal, so that can build you some information to analyze. And then cache bytes, right? This is the storage for temporary. So it would then it would store into the cache. So you can look at the maximum amount. So go down to the memory section, right? It would say, but that is it also have like a peak where that's like a spike in your cache. So in the case that if you have like application issues, right? you might have cache bytes. Or even when we're thinking about like buffer overflow, so processor and storage becomes a concern with like DOS or buffer overflow form of attack. So these things, you can now some value changes, so do an approximate that would probably be good enough for understanding what is normal and what is not normal. Now, once you have your maximum value recorded, you are going to go into change graph options. So at the top, this is your graph with lines. It's very hard to read. So if you put your cursor at the top to the left of your plus sign, you should see the little button with the drop down menu. So you can click it. And in this particular tool, you only have two options, the line or the histogram. I think histogram is a little bit easier to visualize because it's not overlapping so much that it's hard to see. And the colors still come with that, right? But as some of your value changes, your graph also changes. So it gives you the graphical visual. Now you can also uncheck the options to show what is being displayed or what's included. So let's say that I don't want to have everything. I can uncheck some of the option here on the left, right? So that can be used. Yeah, the graph is going to be different from histogram bar compared to your lines. Now here, what we can see is we can look for, right, standby reserve bytes. So scroll down and you can look at some of the options. So your cache reserve bytes are there. So it's like a little bit further down under the memory. So that's basically the option for the system that is dedicated for the standby to be able to store, right? So you can see that there. And it gives you the value. So it's approximately the maximum is what, 2 billion bytes. Take a screenshot so that way you know where to find the information. And then now let's record the data, right? This is how we look at it live for our host, but we want to put it into a data set so we can further evaluate or write up a report. You're gonna go to the left pane of the console. You're gonna click on data collector set. If you click the arrow, it's gonna drop it down. So make sure you click the arrow of that section, that particular feature. And then you are going to define that. You're going to specify it. So you're going to click user define. And you are going to right click, go new data collector set. So you can make you're going to gather a new data set. So you're going to select that and we're going to name it. So in real life, you just name it for your project or, just based on that. So we're going to do CIS-41A, lab 10. Go next. And here we want to focus on specific things, right? Like we talked about earlier, system performance is important to really look at indicator that relates to your CPU and your memory resource, like attacks and malware. So, but if you're looking at specifically for diagnostic, like problems to fix, you can also select that too. This tool is also good for troubleshooting and benchmark troubleshooting. So we are going to select the middle option, which is system performance, and then go next, right? And it's going to tell you that it's going to put it into the perf log admin folder as that name, right? We're going to click finish after we put down the root directory. So if you don't know all the information, you can also right click the the defined data set. And then what you're going to do is you are going to look at directory information. You can look at general here. And it tells you like the stuff that you have added under system performance. You can add more additional counter to it if you want. You can set a schedule, right? And there are many things that you can do with the data set, you know. Again, right? And then you can also delete it, right? So if you want to get rid of it, you can just delete and start all over again. So it's not like a one-time if you do or die, right? Okay. Okay. So once I have the root directory, which tells me where it's going to be located, that should be under perf logs, right? You saw that before we click finish. Now we're going to activate it. So once you have created the how you want to gather your data, you're going to right click and then you're going to click start. Okay. Or you can click it and then you can click the green play button at the top. That's going to allow it to pull the information as your system is being used. So as you can see, right, it's tracing the kernel for your OS and it's adding the performance counter, it's pulling the data. Now, this is not exactly like what you had in the counter in the previous section, only because, you know, we're only looking at your system performance, nothing beyond like we're not looking for additional element like what we've seen in the earlier steps. So let it run for a few minutes. And then you're going to click the little square button or the stop sign, or you can right click and choose stop to be able to stop it from running. So this is a way that we can capture the performance information in a moment in time, right? So I show you how to run monitor real life with performance monitor in the prior steps. And then now that's an active monitoring technique. And then now we're doing a passive monitoring technique. We talked about that today, right? Take a snapshot of your performance information and then be able to evaluate it. Okay, if it doesn't stop on its own, right? Then you can click the stop button. Mine just stopped after a few minutes. And then what I'm going to do is now, right? I'm going to trying to learn and understand the information that I generated. So if you already generated the data set, you would have a report. This won't have anything if you didn't set it up, right? So we're gonna, under the system, it might have system diagnostic and performance information in general, but under the user defined, this is what we specified earlier. In the last few steps, you would see our data set right here. And it's about this computer, right? The computer that we're using to analyze right here. Or we're analyzing this. So in your user-defined data set, you can also browse to the system. So if I'm using an admin computer, I can connect right to that system that I'm trying to analyze to. So when you go through the wizard, like the step earlier, I forgot to mention that you can click browse and then find the system on your network. Okay. Then if you click on that system, because this data set is about the virtual machine system right here, it gives you like your summary information, like your CPU, your process group, your, so information and then the status. And you can also expand the lower components here to answer some of the questions. So click on the host name, take a screenshot to show me that you got there, and then go back and see that this is what it looks like. Then on the information that you're getting from the right-hand side, you can see the CPU utilization, right? Because I use minimal resources of the system. I only see 5% usage. On the server, definitely higher. And then we can see that in the idle state, our system uses about 30% of the 8 gig that we gave it. Remember, this is the virtual machine, not your host machine. So we only gave it 8 gig. And so it uses about 3 point something for the OS. And so you have approximately 5.5 gig left. Okay, so all right. And then on the right-hand side, we're going to expand a little bit more for the CPU. And the CPU, it pulls process services system for you in the data set. And you have to dive into this to get the information that you need. So what kind of things you want to look for? Kernel CPU, because it relates to your operating system for your host, right? Remember we talked about system process at the kernel level, that's protected layer. If you have taken CIS-41, they talk about that. Okay. So look through the CPU section and be able to find your kernel CPU percentage. And typically the columns would give you the mean, the minimum, and the maximum values. Yeah, so, but you want to refer to the state of your system earlier. We captured it when it was idling. So yeah, you want to reflect to what it was. So that means that for most part, your system will be idle if it's not being used. Idling means that it's not used at the top level, right? Like if I'm just browsing through my computer, if I'm not like gaming, my system would likely be in an idle status. But if let's say that you're running a server and you're processing a lot of files, it will not be in an idle state. See how it reports here for idle, right? So you can put down the idle information because that's the data that we collect is really relevant to the idle state. But if you want to go with, the maximum, then we want to focus on that. Like that's if it, like if you, for some people who game, their CPU would be like turbo charge it, right? Like at the max plus some more to be able to, use the resources for the game, etc. So then you would be more relevant to record that.
So it shows me 94.9 CPU. So I think it's 94.9 less or 5%.
5% is, yeah, reflected. 95% is available. So, yeah. So that means that it's like if I have, let's say, 4 engine and I'm only using a very small amount of the first engine, I have 3.5 engine left to use, right? Like in a car, let's say. There's a lot of room. So in an idle state, it should reflect, right? It should correlate with the utilization that you saw earlier. And that's a good, Nima, that's a really good pickup on that. I think that, you start to see that, oh, then I have this much available. And company would want to look at that and say, can we scale? Like, can I run more application on this system? Sure, right? Because you have 95% processor availability at this moment. Like,
It's asking percent of the kernel CPU. So I see this one, but can I add? Do I add these up? Because kernel CPU is asking how many percent.
yeah, but when you scroll to the left,
I didn't. Take
yeah, so it says it's used for, it's at 72%. When it used to, it's only at 7%. So all combined,
What is the kernel CPU?
yeah.
Okay. So I don't know. I wasn't sure if that would be correct, but then I was looking at that.
Oh, so if this is your total, which is your overall, right? So it pulls this information. It already no. So for your core four core use, which is or your threads, if you're
Mhm.
4 thread use, then you can put 4 thread use, then 72%. Because if you just put 72.1%, what does that mean, right? So you need to draw the information in. It's like 4 thread use, 72.1%.
Okay.
Yeah.
And you take that. That's okay.
Yeah, that's okay.
Okay.
But the point is, where can you go to get that information? That's the important, right? And what you how you interpret it. So that's good relevant information. Mm-hmm.
I don't understand the comments.
Yeah, so if it's running, your CPU percentage would be, so these, you see how there's no zero. So it doesn't use your processor. That means that it's not actively running. But let me see. If you click service, not with the S, it pulls the statistic for your services already. And it tells you like the primary services that is running or stop. Yeah, unfortunately, Windows kind of like, I should have tell you to go to service without the S. That's probably more relevant. Yeah, they changed this. They added services and service combined. So service instead of services without the S. I think I mentioned this on Monday. But if you look at that, and you can always shrink it to come back, right? So that way you don't have a lot of stuff. So under the CPU, if you click service without the S at the end, you would see it tells you overall Windows Defender, of course, that's always going to be running because that's your anti-malware on Windows OS.
Yes, I just see 0.1 to be CPU. This
Mhm.
is running, so stop versus me. So it's running, but they're not.
Yeah, because sometimes it runs when there are additional things to check. It's kind of like having a security guard sitting in the front, but he's not like gonna do anything until an event that happens. Yeah. So your application sometimes that it is in a state where I don't want to say idle, but it is actively running. It's not heightened in the CPU because there's not additional requirement for it to block or change or anything like that. So yeah, you do have a very small percentage.
What's considered stop?
Stop meaning that like it ran and it ended.
This
Right. So if it's stopped, that means that the service either got fulfilled or terminated, right? So for example, like I only need to log in one time, correct? Right? Until I log off and log on again, then that service would start and stop. You know what I mean? So you don't always have things that are actively running all the time. Everything cannot be actively running because that way, like, our system would be very busy and it will not be able to. We need a lot of resources then in that sense. Okay. So there's some services that are running and not running, but as you expand the executable, you can actually see like the application or the tool or the service that are related to the executable. So this is a good way to look at malware. Also activities like what if it's actively running, if it's stopped running, if it, so in the case where if your system quarantine it's been ended, that service should not be running. All right. Okay. So when we look at that, and then we are going to go down to system. I think that's still, what was it under? Um, yeah, under CPU also. I forgot. So system will give you a lot of the details, and some of it I wanted for you to focus on, like file and how files are accessed. Because remember what I said, right? System access file for a certain task. Um, like to be able to see the content of, whichever file for the application, and then or update data to the application file and so on. So you see some of that. So you can go down to that section and look at some information. So we're looking at file data operations per second. We wanted to see the performance in how it operates the data, how it accesses the data, read the data, store the data, etc. And you can go down to read write specific if you want. And then we'll look at the processes that are related to the system, right? And that potentially could be related to malware, depends on the malware. And then also the uptime for our system, and then the threads. And threads allows you to have multitasking in Windows environment. Bless you. So we wanted to look at like the mean value so that way we can build out some baseline information ultimately. So you can go down this list and gather the data that you need for your report. And then now we're going to look at connectivity, right? So once you're done, you can click it to shrink it back up. And then go to network. And network breaks down to the area of routing, of, handshake, like based on the protocol suite, like IP, TCP. And your interface is always going to be your adapter that you use to connect to your network. So we can look at like the performance of our network connection for this system.
Does this get here? Because I feel like it's kind of overwhelming.
Yeah, once you are more familiar with where everything is, right? The more practice you have with it, the easier it gets. Like you're like, oh, that's in the memory section. But you have to be more familiar with like how to navigate it. Yeah, they don't. I wish that they have a search mechanism in these apps, but unfortunately this tool was built a long time ago and it has been upgraded in different edition. So you don't have that. And hopefully in the future they would incorporate that feature in the newer version of Windows. But yeah, that will be very helpful. But I think there's ways that you can index it. Okay, so look through, and then if you're using UDP, you can also pull that information. So look at your packets outbound errors. And for the IP section, it gives you like, you know, version 6 and version 4, and then TCP, because there's handshake, it gives you like failed and success. So as you said, right, there's a lot of data to work with. And you kind of have to think about like what would be relevant to what I'm trying to find. As an analyst, you're looking for certain things. So, you don't want to pull a lot. You just want to pull the specific ones that is meaningful in your analysis, because it is overwhelming. It's a lot. So you can clean it up. And it's always going to be here because once you already have it captured, you can always go back and look for it, because it's a moment in time that you got that information. Okay. Okay. So when we look at network, we would see the information, right, about our network. And then the specific protocol, you're going to click TCP and to look at connection fail. And live connection or active connections. And then we look at storage. That's also important, right? Your disk, hot files, and as you would see that there are specific system related files for the hot files. And then we would have a certain files that use the highest resources for writing. Then we look at the physical disk. So physical disk pertaining to your actual drive, right? Like your SSD, your hard drive if you have an old school system. Where logical disk really pertains to um how you allocate a certain section for certain things. Like for example, like in my house, I can have 5 rooms or I can have 2 rooms. It depends on how I section out my house. So the disk is that way. The physical disk is really pertaining to like how it read and write, how it's able to pull data that's physically stored at a certain address location on the actual drive itself, right? Read time, write time, to the actual physical disk, like solid state or HDD or any kind of type of drive that you have in your system. And then again, when we're going to come back to memory and process, and processes are always be relevant to your current system function and activity. So if you have malware, if you have attack, it's always good to start there. So go to memory and then the process related to memory. And we want to look at how it access your storage, memory storage, right? At the highest value. And then temporary locations and errors, cache bytes. And you saw some of the same information from the earlier live monitoring. Now you just, you can go through and you can look at cache faults per sec, commit limit, right? Bye, good night. Okay, so once we have pulled all the details, and so this, why do I make you write it down? I just want you to be able to navigate to it and find specific information that would be relevant. And then you would eventually, pull it together and put it on a report, right? Like if you need more RAM, if you have your system is deficient, if it is if it has more than enough resources, we can have more applications. So performance level is important. And also when you have threat indicators, you would see how it's utilizing your resources. So you would also put that on the report. Let's say you do incident response, you have to go back and pull this information and see, if it's using your resources for specific focus, scope, right? So in the last part, we would look at your report statistic information. So at the end, you can find this section. And it gives you kind of like a summary of your system. When it was collected, this data set, and so a timestamp. So this can be important to be able to track like different data sets throughout when you're analyzing performance over the years, over the days and weeks. So now you know how to use Performance Monitor in Windows system. And in the server system, it's very similar, but it has additional element for services that server would offer. So you have a little bit more in that sense, the components of it. But you're gonna have like memory, CPU, similarly to what you've seen on the client system. Okay. Now in the next part, just be careful how you type. Unfortunately, there's no copy paste, right? But PowerShell is PowerShell. So when you see a get command in PowerShell, that means that you're trying to pull information, right? Where set is when you update the information to the system. So we are going to open up PowerShell, and you don't have to run it as an admin in some cases, like if you are trying to change configuration, then you have to run it as an admin. Remember that our account that we log in is at that level already. So we're just going to open our PowerShell. And if you're getting error, look at the error to see what it tells you, right? Like if maybe, and check the area that the error says. So maybe there's a typo. So we have to type it as it's noted. So get counter space dash. So every time that you see a hyphen or a dash, that indicates the next element to that command, like an option. So we're going to pull the counter list, like what you did earlier in Performance Monitor, right? This is the same way that we use Performance Monitor for some of the counter. And then hold on a second. We're going to pull processor information, right? Underscore total percentage symbol there. And we're going to focus on processor time. Continuous. That means that it's going to keep going. Continuous. Let me make sure I had that right. Continuous. Okay. I think I ran into the same error. Let me see. What did I do to fix it? I'm on the total percentage, processor time, continuous. Yeah, if you're getting an error on 33, just give me a screenshot for that. I have to go back and see. I think I had the same problem. And then you can move on. I think it's still gonna be able to do the rest. But I thought I went back and fixed the problem. Get counter, dash counter, processor underscore total percentage processor time. Yeah, just take a screenshot there. I think I need to fix this command. Sometime, commands get changed through different versions of PowerShell. All right. What we're gonna do is we are going to write basically a script block or script in PowerShell to set up the counter. So you can wrap it inside like a job type. So, and you want to pull like so many entry in that sample, which is 1,000 here. Okay, so we're going to do a start job. So if you're getting an error for that one, number 33, it's fine. Move on. I have to see why. I ran it the other day and it was like, it worked and then it doesn't work. So, and then make sure that we capitalize when it needs to. So you're still going to do a get counter. So you're still going to pull the counter information. And in this case, we're going to do a logical disk. You know how to do this earlier, right? So logical disk, one word, and we're going to do a total percentage free space. And you can do the previous command into a start job like this as well, right? I'm just showing you different ways to be able to, I gotta make sure I type it. to set your counter and gather your data. And you can change the parameter here and make sure we close the curly brace. Okay, so what it does is it creates a task, which is the job. That's what we did with the start job. And then we're gonna run to monitor our system, right? And we're gonna look for the data that is logical disk, and we're gonna focus on free space. I might be analyzing like how much storage I have for free space, right? This would be more relevant to that. Like I said before, in the last one, I should probably put it into a start job. It will probably be better in the start job script block versus running it on its own like that. So there are two ways that you can do that, right? You can just get the counter, and in the start job, you want it to tell it where to end because otherwise it's going to keep running and occupy your processor. So take a screenshot there so that way you know how it looks. And then next, I'm going to do a variable. So I'm going to set up a variable called mem counters. And you can name it anything you want, but in PowerShell, you want to start with the $ for your variable name. And you want to, in your variable, you're going to store, that's a parentheses, get counter. Yes, you're welcome. Say it again.
PowerShell not opening. Yes.
No, you need to put open front asset. Are you using the same machine that you had with the malware analysis? Or you have changed it? Huh? Let's restart the machine. It's, yeah. It's blocking. Yeah, let's restart and try it again. There's something is, it looks like it opens and then it shuts off. So reboot and see. I'm pretty sure it's gonna come back up. If not, call me once you log in and check. Because it's gonna reset the services when you do that. So something is closing it. Potentially it might be something that's installed. Are you using a drive, right? Did you check to see if that drive had been used by someone else for the other?
It was, yeah.
Yeah, that's probably why. So it might be like malware. So let's see if it reboots and it's gonna quarantine some of it or fix it. But if not, you can just download, extract another VM and load another VM. But remove that one. Not remove only. Don't remove everything and then it deletes everything on that drive. So I have to go back and see. Yeah, so if they use it for that last lab, likely that something is running with it, you know? That's why it's doing that. That's why we shouldn't run it from the drive. Okay, so we're gonna have a variable. And then we're gonna do a counter that's stored to that variable. I'm gonna pass that variable so that way we can see. So make sure I have an S there. So once you set a variable, so basically it's a memory location where we're gonna store that counter request or that counter setup or selection, right? We're gonna do a get counter dash counter. And we're gonna pass that variable. So whatever you name it, you would then bring it down. And it's color coded, so it's easy. The information is not very nice in display, but you do get some information, right? Like It shows you the same thing like cache bytes. Remember that this is in bytes. And we saw earlier some page fault input, cache faults, right? So you get the same information that you get earlier in your performance monitor. I think, give me a second. I think that you should download a new VM and extract it from the lab page. It takes like 7 minutes, likely that you run into, but you can check. And then you don't have to restart. You don't have to redo a lot of the things. You just pick up what you left out, like open the VM and run. Yeah. Yeah, so when you did this, so basically you're running a script, but it should, where were you? That was in the last scroll up. Yeah, so it should not take you here. It should also give you some kind of display. Press Control C. Okay, now you're back. So you need to go back to the last step. You need to have an output for this. And then check your so you're missing curly braces. So yeah, you need to wrap it inside the curly brace. So check your syntax there. It should have some kind of output for that one.
That was the first one.
Yeah, if you did this one, you should have some kind of output here. It tells you what it's doing here. So you should, you should be able to see something there. It should not just like not show anything. So check your color brace. It should have your dash counter should be like color coded as well. Yeah, that's a start job, right? See how when it does that, when you have a hyphen, that's the next section. It's not part of the command, that's an option, so it should change the color.
I have.
You just have to type it again.
I can't compare.
Yeah. So it didn't put it in buffer, so you just have to type it. Yeah, likely that if it's not color coding the get and the start job, that means that it's missing the symbols, the characters, like curly brace, parentheses. So check those. Okay, where were I? I did this one, right? And then take a screenshot. You should see it as equivalent to what you've seen in the performance monitor, but it's not organized in a way where, right? You see it right here, where it's in columns. So it doesn't have, in the console, it's going to be text-based, and you're going to have to look through so it's not too formatted, okay? But it has the same information, it should. And then we're going to also create another variable for 37. Bye. Have a good night. So I'm gonna do step 37 now. So how was it? Did it go?
Yeah,
Is it slow to load?
yeah.
Okay. That's a machine that we restarted? Oh, because it's updated. Okay. So it's good?
Where?
Using the wrong. It's curly brace, not parentheses. After script block. It's a curly brace. Yes, the wrong symbol. Control C, get it back to the pop-up, and then fix the symbols. Okay, we are setting a variable called counter. Like I said, right? Anything you want to name, just use the dollar sign in front of your variable name. And we want to be relevant to what we're doing too, of course, right? Did you get it? Okay. Yeah, so open and close.
There we go. Something.
It's good. Troubleshooting is rewarding sometimes. Okay, so once we set the variable, we're going to use it. So now in this sample, you notice that we're passing a 0. So it's going to be only the first instance. That means that the first core. Remember, we have 4 core in our virtual machine. So whichever core you want, and the first core is instance 0. So if you want to do like the 4th core, then you would have instance 3, right? So we're gonna focus on the processor time for the first core. So what we're gonna do is we're gonna do now we're gonna pass the variable, or we're gonna use it with the method counter samples. And we're going to use index 0. And as you look at it, right, it's going to be instance 0. That's your first core, your first processor. And the cooked is 0. So it's nothing. But if you can change it, you can change it in. So before you copy paste, Mitchell, make sure you check the folder on the drive. If it has a prev and a log, don't. Okay. Download. I'm going to tell you to save you time. Just download and extract. You're probably better off doing that from the actual lab page. So just, but anyway, whichever that you think that you like to do, I recommend download and extract and run the virtual machine. That's a fresh one that I upload.
Already.
What do you mean? Just delete. Delete the ones that you just used and broken.
Yes, it's already, not, it's all extracted.
Yeah, then run it from that extracted one, but check. So let's go back and see. Did you run that one and it's having problem? It shouldn't, because I'm using the same one that I downloaded. So it should be in your downloads folder if it's downloaded and extracted. Okay, so are we clear about the index value that we put here? Yes.
Error.
Because you did create the variable successfully here.
Took a minute. You were at.
in the process. Well, I believe that still being it was still some of the university.
39. 30. And about like 2 months in. Okay,
Well,
37.
yeah, because on the next I'm bringing I got an issue with it here, and then what I did was I advanced the later. Names.
Not this.
Sure.
Good night, President.
Good night.
Everyone in the- That's what.
Yeah.
We run them. Oh, yeah. Like once a week.
Yeah, I can barely see it. Just this. Dude, I can barely see this in front of me. But this, it's okay, but.
Let's say that. When you still be there.
So. Skip this one for now. It's similar. That's not run it with Let's see if that works. Yeah, I ran into that's it's just a glitch for PowerShell sometimes it happens. Yes.
I have a question for, I don't remember really mistakes and asking us, oh, this thing from that, so I'm just making sure I understand. So I said yes, because technically, because the goal is to learn how to do it properly.
Yes. So in the earlier step, you saw that you can get the memory value information, the counter.
I like that one.
Yeah. Yeah, so but you know that on the server you might not be able to have a server with a desktop, right? So they don't you have to do PowerShell manually. So this is you don't you go to Microsoft website and they have documentation on this. So on your phone I don't remember all of it, but the technique is you can set a variable and then use that variable and you can so yeah so yeah so press Control C and repeat Control click on your PowerShell, click it and press Control C. All right, it's all over again, but check what you had. Yes, I will take this. Yeah, so I think similarly, someone else is always having the same problem, but you can check. So if you guys are running into issue with step 37, which I don't have issue with, right? Then you can skip that and come back to it. It's potentially the way that I look at it, because I try to look into this problem on Monday. maybe that it cannot recreate that location for your variable, and that's why it's throwing an error. It's hanging up that space that's used is hanging up because you had other variable that is set that's being used in that space, and that's a PowerShell thing. So you can not, if you check everything and everything worked, right? But you can try to retype it. So I did 37 and it is successful. It is shown here that I have an instance 0, right? It would look like that.
My first one got one.
But if you have checked a few times and you retype a few times, and if it's throwing an error, that might be also a common issue. So just do 38, which is the same, but eventually when I did this on Monday, eventually it released that section of memory and I was able to execute it. It's just because we're also using virtual machine and it is limited. So, I'm gonna do 38 with you so you can see we set the same variable, right, as 37. So technically you don't have to set it again if you did successfully, but if you didn't, you can try to retype it. And then so now I'm gonna use the variable name with my method or my routine. And I'm going to add the operator, which is the pipe, right? Where I would add another criteria to this. Yeah, so if it's not taking it, try to progress to the next step. You're going to use the same variable again. But the point is that in 37, we're looking at that particular core in the processor for the processor time percentage. Cooked value, and that's an LT, not an IT. L as in Larry, lowercase. Where we want to look for anything that would be, 20, not 30.
No, the second one.
So it would look something like this, right? You can also attempt to reboot your virtual machine and open PowerShell and pick up where you left off. You can do it that way so that way it would give everything back to the system when it restarts. So you can attempt that. It's a quick restart. Anyway, 38 looks like this, where we have values. So what I did was I looked through all my instances, right? And you would see the processor time that's a counter under processor. So the item under processor counter where I'm gonna look for, so it's gonna give me percentage processor time for all my core. So this is another way that you can do all core, where in the last step you would put the index for the actual instance. But double check your command, retype. And then I'm using the same variable, so you need to set the variable again, right? You just up arrow key. So if it throws an error, go through and check it. You can also rename your variable something like counter1 and just make sure you use the same thing in the next line. We're going to set a second variable called proc, P-R-O-C, S, and we're going to store another counter. But going back to your question earlier, how do you remember all this? Practice, right? Just like how you remember ping or trace route. I know it's lengthy, but a little bit of programming logic as well. So now I have the second variable set one is counter and the other one is for processes, so PROCS. So now I'm going to use that with the counter samples function. So what we can do is we can filter and sort it. So in this case, we're going to go descending order, right? That means high to low. And we're going to try to format it as a table. No, so in 39, the last line is one long line. The last two right here, this is a complete command. Okay, so make sure you continue with after you put in format table and then space. So I'm gonna expand to make sure I type. Okay, so format table and space. We're gonna do property path. Instance. Okay, so now let's shrink it back so I can see and type instance name, hooked value. We're gonna auto size. Oh, I'm missing a hyphen somewhere here. Let me see. Oh, yeah, my descending should be together. Bye.
Bye.
Oh, I had a type. For which one? For 38, 39?
Both companies. So just get the one
Just
about-
maybe reboot your machine and then just go to PowerShell and go to 37. Try that to see if it releases the process and you can do it. I think it's hanging it up. If you check your typing, that means that, yeah, go to power and then restart. So for 39, it looks like this. Okay. So yeah, there should be output for every single one, ideally. Then I would be able to see all my processes, but it's going to go descending order. So you can format it like this. So make sure we do a complete command for the last two lines in 39. Take a screenshot. Now, when you're done, you can do an exit and then you can boot your Kali Linux, which I have 15 minutes and I will go through it for 15 minutes. Sorry. Let's do exit here. And it's going to get laggy as you can also do Control C. I might have to do that. If you want to. You can also knock out. So if you have challenges with 37, 38, 39. You can always attempt it on your home computer if you have a PC, you want to try it. But this has to be run at the level of, I don't think you can run it on the school computer because you have to have the privilege to do it. I won't have a big deal if you don't have the screenshot, right? But yeah, it's just different ways to show you how you can organize your data. Because you know how to get processor time in your performance monitor, but this is a way that you can set up your variables and run it. So try, after you reboot, you can try. If not, move on to Linux. So I'm going to do that now. I'm going to go ahead and run Kelly.
Well, we don't finish today.
Yeah, you can come in. I'm here tomorrow, Monday. I came to campus yesterday, but I had to evaluate. So I'm usually not available on Tuesday because of meetings and other tasks. And people utilize this room at a certain time. So, all right. As Windows is updating and shutting down, I'm booting up Kali Linux. And after that, I'm going to go ahead and log in. So again, you have to download, extract, load Kali to VirtualBox. We should be comfortable doing that. Now, when you do Command 50, no period, right? That's just a period in that line, so I can start a new text line. But top, no period. Okay, I'm going to log into Kali Linux. And I'm going to open my terminal. We're going to do a top command. Top is like what you saw on the last step. It gives you all your processes that are running. The last step of the previous section, I mean. Or when you press Control-Alt-Delete on Windows System and go to Task Manager, you see all your executable, all your processes, right? So the PID is your process ID. It also identified the user that is using that process, or the user account that's using that process, I should say. Virtual memory, CPU percentage, memory percentage, and then the time that it uses that. So take a screenshot, and then on the top, it tells you the total task. So we don't have to count everything up, right? How many tasks are running, and it's going to tell you the running task, right? So the number to the left of it indicates the process information and its state, right? So the state is here and the number is to the left of it. That's what I meant. And then the sleeping ones are the ones that are not utilizing the resources, right? So what's the difference between sleeping and stopping? Sleeping is just like it goes into a mode where it might be waking up again, so it can be reused again. Where stop is that it ran and then terminated. So that's different. And then there's also zombie-based state. So you can see the type of processes that we're using. And so you can go through and answer the questions like memory, cache, swap, memory. And then if you want to look for virtual memory, you're going to do a VStat. So when you finish answering the question, you're going to do Control-C to stop monitoring there. And then you're going to do the next command, which is vmstat, which gives you virtual memory usage and details. Yeah. Always come back. I have the same problem. Just do that and then go to. Yeah, I have a similar problem today. And on Monday, it wasn't a problem for me, but then the 37 was a problem, but anyway, yeah, so you can move on to 34. Okay, so in virtual memory, it tells you, swap, system, CPU, processes. You might have to expand the screen to kind of look. Sometimes it's not very specific to the column like this when the resolution is different. But anyways, you can see the buffer size under buff, right? You can see swap under SWPD. So I have 0 here and I have the buffer size here. So now we're going to do list open files, which is LSOF. This is important when you're looking at active files that are being used by systems or user or application, especially when you're looking for threat or indicators of threat. This is a good command to kind of think about when you're looking at files that are open. And it doesn't necessarily be a user account. It could be a system account or a root account or an application that uses the root account. So take a screenshot and then look at the list, what information is displayed. I should have, it's a long list because Callie got a lot of things running, right? It should have like the path, the location of that particular file, the user account that is accessing the file. But you can scroll up to the beginning of the list and find the information, the column listing.
Second line, I actually can't read that, but I can
LT. Else is in Larry.
Case?
Yes, lowercase l.
I don't look like that. Looks like one.
It's the font.
Making sure.
Yeah, LT.
Oh,
Okay, so we got the LSOF now. We're going to do the next command, which is your PID stat, which is and it tells you what each command does, right? This is a way that we can look at the Linux kernel, and it's when we need to look at the sub processes, because processes have child processes, the sub processes that's executing the task. So if you're looking at malware, if you're looking at application that uses sub processes, this is important. So it gives you the detail of the child processes versus just the parent process in the prior like top or another command. Okay. And then you can look for specific sub-process by a user. So we can do PID stat -R, right? Dash uppercase use Kali or root or whichever user account that you want there. And it would only list the sub-processes for that particular user account. Okay. Now we are going to use this entire command. And again, you can copy and paste this if you don't want to type for Kali Linux, you can. What we're going to do is we are going to list the active processes, right, for all the users, including the E user, the R user, the S user, so all the users. So as you can see here, it's going to list the Kali, the root, the account. So your E users are your root users. Your R users also include root and Kali users. So you can go down the list to distinguish, right, the different groups of your user. And then for the label, it would be confined, or I think it's unconfined or confined. So in this case, for the most part, it's unconfined. And then the command you can see, right? So it is also PS is for active processes. about the users or the users are accessing it. Now we're going to do the process for the root. So PS underscore U and root. So you can list all the processes that the user root is using. And it is ascending order, so you can go to the last one and that will be the highest CPU percentage, right? Now you can do IO stat, which is used for input and output devices. We're gonna do percentage system. So you can see that here. So the user, we can see that that's about 0.88 for the user side, where the system is much higher for input output. Of course, because when it reads your file on the disk or something, it's going to need to use, the output. And then when you save file, then it's going to be input. So your IO is used for software to hardware level. So what you see there. And then there's also idle and IO wait. So it queues that. So you can see the details by using the IO stat if you're interested in looking at input and output for your resources. And then we're going to have to do sudo TCP dump -D, and it explains to you what that option D is. It's going to print all your network interfaces. So in the server environment, we would have more than one way to connect to the network. And then we're putting the password. So these are the list of these are ways that I can connect to the network. My Ethernet connection on my virtual machine that is up and running. My loopback is also up and running, whereas the other ones are not specified, right? So you would see. So if you wanted to check your network interfaces on your system, this is what you do. TCP dump -D. And then I have 2 minutes, so I'm going to go all to 60, like what we planned. Sudo TCP dump. TCP dump is a very important command in cybersecurity, so practice. We're going to do account 10. And we're going to have a verbose, so it's going to give us some details, right? It's listening, so it's waiting for traffic. So basically we can capture 10 packets this way. We are going to open up Firefox and we're going to put in google.com. And then minimize, you can refresh it a couple of times. And minimize your screen and you would see, right, the packets for your web activity to visit google.com, where this is my virtual machine IP address. It tells you the port information because it's Firefox, right? We're pushing it through Mozilla. You have some quadruple A records and A records there. So TCP dump is very cool when you're capturing the packet. It tells you, of course, in the console or in terminal, the details about your network traffic. So this is another way that you can filter out your packets and capture your network packets. Yes. And then run some commands for part C with Kali. They're easy command. So for 61, I visited google.com, right? I'm going to run one more and then I'm going to stop, right? So you're expected to go to about 60. So free or to the end if you want to practice. So for free-m, this is gonna display the memory sizes in your system. And right, so we want to look at the use, the total, the free, the cache. So this is another way that you can also look at memory in Linux, Debian Linux. But you can use systat, you can use SAR. There's so many tools that you can use with Linux. Maybe I can do two more to the end. But like I said, if you can get to 60, I'm happy. So systat is not equipped with the Kali version that we're using. Oh, maybe it is. Actually, I take that back. So it is already installed, maybe in the other version. And then what we're going to do is we are going to SAR 1-3. So we can also use the command SAR from systat to pull information about memory usage, right? So this is another way that you can look at your memory usage, like buffer use. And then we're gonna do a SAR Q2 5, where we can look at the queue length and the processes. And then I'm gonna run a quick update. We are going to do IO ping. Oh, wait, what? Sudo app update instead of install update, because if it doesn't download, then it won't pull. So app update. All right. Once I update, I'm going to install IO ping and use IO ping for the last exercise requirement, which takes me a few minutes over. Okay, so sudo apt install IO ping. And I can use IO ping similarly to what I've used in TCP dump, where but IO ping allows me to look at the actual in this command, right? We want to look at IO, but only for input and output. So earlier we're looking at, network traffic with TCP dump. IO ping allows us to look at IO access rate. Okay, so we're going to do IO ping count 10 -C10 S1M TMP. You're going to put it there. So it's going to go 10 requests. Basically, it pings your input and output information, and it's going to gather the information. It's going to give you 9 requests completed over this time, right? It's able to read and write at a certain rate, where your so to the left is going to be your minimum, right? Your average is next to that, and your maximum is following, and so on. So you can use that to look at your input and output rate. This is another tool that you can use, and that completes everything. Okay.
You better slowly.
Good. Good. That's my main goal, is to get you through the process and trying to reflect and say, what did I do wrong, right? Can I go back and fix the problem? I mean, it's a learning process. I make mistakes too. You see typo, syntax sometimes. Okay, make sure we answer the last question if you stop earlier, right? What did you learn about Windows Performance Monitor? You learn how to add counters. You learn how to be able to do live monitoring by adding the counters. And then you also learn how to create a data set for passive monitoring. You also learn how to look at the data.
As
61 is ideal. If you do 60, you have to do 61 to see any kind of result. But yeah, 61 is ideal. You know, the other class they ended up stopping about right before that, but what did you learn about Linux monitoring? We learned how to use different commands like top, TCP dump, to look at network. We learned how to use, so you can go back and look at the commands that you have used for Linux or IO ping. And how can you apply in this concept? We talked about that in length in lecture on how you can use it to identify threats, to be able to monitor your system performance for growth, for scalability, and also for availability and different areas of cybersecurity.